COP1, COP2, and Clathrin are coat proteins that direct protein and membrane trafficking in between compartments of the cell. Importantly, there are major differences in the direction of travel and cellular functions utilizing these coat proteins. In this video, I'll share my visual mnemonic to help you recognize and remember the similarities and differences between these coat proteins. Let's start off by looking around. Yep, we're in the post office, or the shipping center in town. By the way, a shipping center makes me think of the Golgi apparatus, often called the shipping center of the cell. Indeed, these coat proteins are especially important at the Golgi apparatus, where they're often responsible for determining direction of travel. Just remember our shipping center to peg the Golgi, okay? Alright, now let's introduce the characters in the scene. Just like how there's COP1 and COP2, we've got two cops right here. And the cloth-covered guy they're chasing? That's Clathrin, also known as Clathrin, the famous mailroom bandit who's been stealing important shipments. We'll get back to our Clathrin guy later, but for now, let's focus on the cops. Yeah, just take a look at our first cop here, firing his gun. Man, that gun's got some crazy recoil. Looks like it's really knocked our cop backwards. By the way, gun is Pixarize's recurring symbol for the number 1, because gun rhymes with 1. Get it? So this cop is our symbol for COP1. Next, notice how the gun's recoil is pushing this cop backwards, which coincidentally helps me remember retrograde transport. You see, the general secretory pathway of proteins is as follows. Proteins are made in the ER, move through the Golgi apparatus, and are eventually secreted via the plasma membrane. In this context, COP1, short for coat protein 1, is responsible for directing vesicles the other way, from the cis Golgi back to the ER. This backwards direction of travel directed by COP1 is also called retrograde transport. There's a lot of reasons why you would need to transport things from the Golgi back to the ER, but one commonly described is sending back escaped resident ER proteins. That is, proteins that were never supposed to leave the ER in the first place. Anyways, our cop gun's recoil backwards is a great memory peg to help you remember that COP1 directs retrograde transport. Next, take a look at the other cop who was chasing our cloth-clad bandit. Yeah, he's running really fast in those new shoes. Wait a minute. Shoe? Isn't that Pixarize's recurring symbol for the number 2? Because 2 rhymes with shoe, duh. Anyways, this cop with shoes is here to help you remember COP2. And what do you do with nice shoes? Run forwards, of course. Looking at this guy's forward lean, he might qualify for the Olympics. His forward direction of travel is here to help you remember anterograde, or forward transport. Unlike COP1, COP2 is responsible for directing vesicles forward from the ER to the cis Golgi. We've already covered the secretory pathway, so it's pretty obvious why we need vesicles to move in the anterograde direction. Just remember this cop with shoes running forwards, and you'll remember COP2 directs anterograde transport. Last but not least, we have our cloth-covered man. No one knows why he wears a cloth. Perhaps it's to cover his face so he can't be seen stealing the mail. In any case, this cloth helps me remember Clathrin, because cloth sounds a lot like Clathrin. Get it? So what does Clathrin do in the cell anyways? Short answer, it's complicated. Clathrin has tons of functions, but for most purposes, you only need to remember 2 important ones. First, take a look at the ice box our cloth man has knocked over to escape from the pursuing cops. Yeah, take that. That'll slow them down real good. By the way, an icebox is Pixarize's recurring symbol for the lysosome, also called the isosome. Yep, one of Clathrin's important roles is to direct proteins from the trans-Golgi to the lysosomes. Just remember our icebox here to peg Clathrin's role in sending vesicles to the lysosome. Next, notice how our cloth man is casually swigging from his bottle. Yeah, he's clearly not too worried about his situation. So casual. Anyways, this consuming action should remind you of endocytosis, or the taking in of matter at the plasma membrane. Clathrin plays an important role in receptor-mediated endocytosis, and one example commonly cited is its role in the uptake of LDL from the blood. Yeah, when LDL binds to LDL receptor, the subsequent invagination and endocytosis is mediated by clathrin. One other special form of endocytosis mediated by clathrin is pinocytosis, which is the process by which cells take up liquid. And of course, that's exactly what our cloth-covered man is doing, swallowing up liquid. How convenient. Again, these two functions are just some of the most important and therefore testable roles of clathrin. Less important roles include clathrin's place in exocytosis, like calcium-triggered exocytosis. You can remember our cloth-covered man leaving the building to peg exocytosis if you want, but then again, this just isn't that important. Just remember transport to lysosomes and endocytosis, and you'll be set for 99% of questions you might encounter on test day. And that's it for our coat proteins. Let's recap quickly and get out of here. COP1, COP2, and clathrin are coat proteins found on membranes that help direct vesicular transport throughout the cell. They are found in many locations, but are especially important at the Golgi apparatus. COP1 is responsible for retrograde transport, sending vesicles from the cis-Golgi back to the ER. COP2 directs anterograde transport, sending vesicles from the ER forwards to the cis-Golgi. Clathrin is a coat protein with many functions. The most well-studied functions include directing transport to lysosomes and its role in endocytosis. And that's it for COP1, COP2, and clathrin. With this simple mnemonic, hopefully you'll never confuse which way each one goes. Speaking of the post office, feel free to send the Pixarized team any love letters you want. Or just follow us on Instagram where you'll find photos of David's hot bod. Either one. We'll see you next time.